Okay, good evening everyone. Okay. Today we will study a topic called gravitation. Gravitation. It is important for the CBSE as well as JEE. Okay. Under the gravitation, mainly we will study Kepler's law. Okay. Gravitation. This topic we are going to cover today. Under the gravitation, the Kepler's law we are going to study today. Okay. Kepler's law. The first law of the Kepler is called as orbital law. Orbital law. The second law of Kepler, it is called as law of aerial velocity. Aerial velocity. In third, it is the law of time period. These three laws we are going to study today. Okay. These three laws of Kepler, which come under the topic of gravitation, we are going to study today. First law, let us move to the first law, that is orbital law. First law, that is Kepler's first law, orbital law states that Sun is in the center and all the planets revolve around Sun in the elliptical path. Okay. All the planets revolve around the Sun in the elliptical path, and Sun is at one of the radii of the ellipse. This is the first law of Kepler, that is orbital law. Let us discuss few things about ellipse. Which mathematical shape will be called as ellipse? Okay, ellipse is nothing. It is a group of points which satisfy one condition. What is that condition which satisfies? All the points which lies on the ellipse, they are equidistant from two points that are inside the ellipse. These 2 points are called as radii. Okay, radii of the ellipse. What is the condition? Every point will be equidistant from this two radii. Okay, let us consider any point. For example, let it be this point or some other point here. These 2 points will be equidistant from every point which lies on this ellipse will be equidistant from these 2 points. These 2 points are called as radii of the ellipse. Okay, and that was the Kepler's first law. Okay, planets revolve around the Sun into the elliptical orbit, and Sun is at one of the radii. Okay, now let us move further. That is Kepler's second law. It is also the law of aerial velocity. Aerial, this word came from area. Aerial velocity. Okay, where this word aerial came, aerial means it came from area. Okay, what does this law state? That key area swiped by the radius vector, okay, is constant. I will explain it through the figure and a diagram. This is the Sun. All the planets are revolving around the Sun in the elliptical path. Okay, the line joining the center of Earth and the Sun, it will be called as radius vector. And what does this law states that? Suppose this is the planet. This is one planet. It is revolving around the Earth. At some instant, it was at this point. And in time t1, the planet moved from here to here. In time t1, planet moved from this position to this position. And then the area swiped by the radius vector, it will be this. Suppose this area is A1. And here, suppose at certain different instant, the planet was here. From this point, it moved from here to here in time t2. The area swiped at this point by the radius vector during this journey, let it be A2. Then, if t1 is equals to t2, then a1 will be equal to a2. This is stated by the second law of Kepler, that is aerial velocity. It states that area velocity is constant, that is area upon time taken is constant. Area swiped by the radius vector is constant. Area upon time, it is aerial velocity is constant. Aerial velocity is constant. Okay, it is given by the second law of Kepler. Now let us move to the third law of Kepler, that is also called as time period. What does this time period law says? T square is directly proportional to a cube, where T is the time period of a planet, the time taken by the planet to complete its revolution around the sun. And A is nothing, it is semi-major axis. Suppose this is the ellipse. In center there will be sun. In center there is a sun. Then if it is ellipse, it will have a major axis and a minor axis. Then this A is nothing, it is just the length of semi-major axis. That is half of the major axis. And it is nothing, it is the time period, time taken by planet to complete its revolution around the sun. Okay. This A, again, it is first of all semi-major axis, that is right. Also, okay, again, in many questions it is given that average radius of the planet from the sun, it is, okay, so A is also the average radius. Average radius means the motion of a planet around the sun. It is actually elliptical, but theoretically, for the calculation purposes, it can also be converted into the circular motion, okay, circular path. So at that time, whatever radius will be there, it will be called as average radius. Okay. This was all from my side, the 3 laws of Kepler under the topic gravitation. Okay. Later on, we will study other topics.